Thank you for your introduction, and nice to meet you again, everyone. This is Mengyao. I'm from the Ocean Policy Research Institute. I'm a colleague of Emma Zhu, and today I'm so honored and happy to be here to do some presentation to share my research. So today I can talk about a research project I was involved in. It's called Building a Digital Ocean Society. So my topic is almost focused on the marine digital transformation part. And in this project, I'm focused on to introduce our outcomes, that is visualizing the annual transformation of ocean policy in Japan using text mining technology. So about our research project, the Building a Digital Ocean Society. So our aim is to realize the Society 5 in the ocean. So what is Society 5? In a very brief word, now we are in the Society 4. The Society 4 has a lot of problems and we need to solve. And in Society 5, that means we can use the big data and also by using the artificial intelligence to connect the cyberspace with the physical space to solve a lot of problems we are facing now. Of course, in the ocean or in our society. So our project is called the Building a Digital Ocean Society. That is to gather the wide variety of information from the ocean and through the use of big data in the ocean to achieve an advanced fusion of cyberspace and the physical space in the ocean. And there's a two main pillar in this project. One is called the ocean visualization, and another one is the ocean space collaboration. So with these two pillars, we want to have a better marine domain awareness, and finally we can realize the Society 5 in our ocean. So today I gonna talk about why we're going to use the text mining to analyze the marine policy. Actually, as you are or you mentioned that the sustainable use of our ocean is very important, including solving marine issues scientifically and become more scientifically. We need more data. But with the rapid development of the diverse ocean observation technologies, ocean data actually grows very fast in last decade, and it almost forms the ocean big data. But the study of the data based on marine policy making is still inadequate. Now, as a Ocean Policy Research Institute or Ocean Policy think tank, we think it's very important for us to promote this kind of data-based marine policy making, and especially for the utilization of the text data of the marine policy is very important. So actually in Japan, there are a lot of ministries exist that related to the ocean. For example, there are Ministry of the Agriculture, Forestry and Fisheries, and also the Ministry of the Land, Infrastructure, Transport, Tourism, and the Ministry of the Environment and so on. So all this kind of ministry just influence or determine some kind of marine policy, and they published a relevant white paper each year actually. So as a result, the policy interaction among this ministry in Japan is very complicated. A quantitative and simplified quantification of these policies is essential for improving ocean governance in Japan, also around the world. However, to our best of knowledge, the temporal trend of the ocean policy in different ministry has not been examined based on some technology, for example, the text mining analysis. So our objective is to use the text mining to analyze the text data from the multiple white papers to comprehensively visualize the annual transformation of ocean policy in Japan and to clarify the similarities and differences in their concerns on a hot topic of various ocean-related organizations that published the white paper. Our method is including 5 steps. The first one is, of course, the data selection. We select the white paper because the white paper is an annual report outlining the status of the political, environmental, social, and government measures and published online and available to the general public. So everyone can check out this white paper, and this white paper plays a very important role in policymaking process. So we choose 3 different kind of white papers. The first one is a fishery white paper, which is issued by the fishery agency in Japan. Another one is the environment white paper, is issued by the Ministry of the Environment. And the last one is the ocean white paper. Actually, it is issued by our OPRI, Ocean Policy Research Institute. Next is the data collection. Of this kind of white paper just published online in PDF files. So we just use some AI technology and also with the manual to extract the data from the PDF files by excluding the figures, tables, footnotes, footers, and so on. And so this is a kind of time-consuming step actually in this study. And then the step 3rd and 4 is about the data pre-processing and data mining. We do this 2-step in an application called Cage Coder to automatically analyze the text data by and developed by a college in Japan. So previously we do the morphological analysis. This is the analysis to segment the sentences into words. And then we do the LJ topic model. This is a model, a natural language processing technology to discover the patterns of words and summarize the underlying topic structures in our text data. The last one is interpretation of the result. In fact, the topic model is an unsupervised machine learning technology. So we need to do some expert interviews, for example, to interpret our result, to make sure our result is find the right way to all of the text data. So we do 3 kind of expert interviews were conducted with officials from the fishery agency, from the Ministry of the Environment, and also from our inside OPRI. So as a result, here's a correspondence analysis result. This is a multivariate analysis that maps multidimensional aggregated data into a 2-dimensional space to visually represent the relationship among the data elements. So as a result, you can find that there are 3 groups very perfectly divided. So each group just represent each white paper. So we can tell that each white paper just have their own topic. And then we just analyze the numbers of the topic for each white paper. For the fishery white paper, there are 14 topics. The environment white paper, there are 20 topics, and ocean white paper, there are 18 topics. So I'm gonna introduce one of this result. This is the 14 topics of the fishery white paper. We can have for each topic, we can get the top 10 terms with their probabilities of their occurrence. So based on this top 10 terms. We can summarize each topic. For example, for topic 1, the first word is the resource. The second one is the secure. The third one's a technology. So based on this kind of terms or words, maybe the topic 1, we can summarize the topic 1 as a technology and system for securing the fishery resource. And then we have the LG heat map for these 14 topics. So this heat map is actually an annual transition of these 14 topics, and the color scale just represented the proportion of each topic in each year. So we can find some hot topic in some years, and then we will do the cluster analysis for these 14 topics. As a result, the 14 topics just divided into 4 clusters along the time. So the ends for each cluster have their own hot topics. So we can tell that in the fishery white paper, the hot topic just transferred very clearly by the time. Actually, the major transition in topics occurred all of these 3 white papers over the time. Though for the fishery white paper and the environment white paper, so actually this two kind of white paper just issued by the government institution. So this topic transition were mainly caused by the revision of the relevant laws. And speaking to the ocean white paper that issued by us is NGO. So this topic transition will closely relate to the development of the worldwide ocean initiatives. And the expert interviews revealed that the experts' view on the topic and the transition of the policy focus were generally consistent with our analysis result. And here I want to pick up one of the big issues, that is the Great East Japan earthquake just happened in 2011. And to this kind of big issue, all of the white paper, the 3 of the white paper, just all responded. But the responses and the reaction differed among the ministry, and each ministry or institution had different interests or their unique topics. So the fishery agency just responded in 2011 very rapidly, and they're concerned are resource management and the fisheries. Our OPRI just responded in 1 year later in 2012. We are concerned is the tsunami damage and the related education. The Ministry of the Environment responds the same year 2012. Their concerns are nuclear regulation and power generation. So to conclude our discussion, the text mining provide a very singular and clear picture of the overall framework of the white paper, including not only more concise topic and their annual variation, but also topic transition, which provides scientific reference for future policy decisions. And it is possible to efficiently analyze the vast specialist among annual report using the text mining to obtain useful information, even starting point. But as an unsupervised machine learning technology, the interpretation of this result requires relevant expert knowledge. For example, we can do the expert interview. So as to our topics today, actually, I think the collaboration between Japan and India is very important, and there's a lot of things we can do in the future. But maybe before the collaboration, of course, the data-based science, the nature science is very important, but the data-based social science, for example, the analysis of the policy for each country, for India, for Japan, by analyzing the policy, maybe you can find the difference and the similarity between us, and we can find the gap. We can find the collection point by analyze our policy in our country. So I hope maybe we in the future we can this taxonomy of the policy can be used for our collaboration as a start point. And that is all from mine. Thank you very much for your attention. ご清聴ありがとうございました。